Assalamu alaikum everyone. This is 12th lecture for CS 116 Object Oriented Programming. This week we have been discussing inheritance, and in the last lecture we were discussing this method overriding, and we saw that method overriding can be used to completely replace a parent's method or to extend functionality of any of the parent's method, right? And both things, they can be done through method overriding. Apart from this, we also studied this render method str for pretty printing of an object. In today's session, we'll see how can we extend functionality of built-in classes. Like we have been using these classes like list and integer and float. So today we'll see how we can extend functionality of those already existing classes. Or you can say that we'll see how we can inherit from built-in classes and what advantage does that provide. Let's see an example. In this example, what I want to do, I want to create my personalized phone book to keep track of my contacts. Now, the approach that I'm going to take today is I won't be jumping to the most appropriate solution directly. But what we'll do, we'll explore, we'll see what options are available for creating this phone book, and then we'll weigh them against each other. We'll see pros and cons for each approach, and then finally we'll reach the best one. Okay, let's start with the thought process. Like, let's first think that what kind of data I want to put in my phone book and what kind of operations do I want to perform on that data items or on my contacts. So I decide on 3 data items: name, phone numbers, and email address, right? And most probably I'll keep all of them strings. I can keep phone numbers as integers also, but that will create problem while printing and other stuff. So to keep things simple, let's make them all strings, right? Okay, this is a kind of database. Like when you are creating a phone book, that means you are storing records or data in a specific manner, right? So we know, we are pretty much familiar with the common operations that we perform on a database. I can add item to my phone book, right? Then I can print or view all entries of my phone book. Then I can sort those entries, like I can sort my phone book in alphabetical order, or here, okay, let's stick to just one sorting technique. I'll sort this book by name. And then I can search any item based on first name or last name. So these are the 4 operations that I'm going to perform on the data or the contacts that I'm storing in my phone book. Now, how can I store data, or how should I start writing code for this phone book? There could be multiple options now. The first option that I'm considering is that I store my phone book in some built-in class like list or dictionary. This is the approach that we had taken in the database that we created in last semester also. So this is the simplest approach. So first see how we can do this, and then we'll come to the next 2 approaches. So first, let's compare these 2 data structures, list and dictionary. We'll compare them on how we can store data in them, and then we'll see which of these 2 classes provide more built-in functionality to implement these functions that I want to add to my phone book. In list, I can store the data in a 2D list. Like I want to store name, number, and email for each contact. So I can make a small list containing these 3 attributes: name, number, and email. And then I can add as many such items in another list as I want. So this is a 2-dimensional list. And I hope this is not very difficult. We know this format very well. Now, when it comes to dictionary, we know that in dictionary we store data in form of key value pair. So that means I have to choose one of these fields, name, number, or email, as key. So the most appropriate field that can be set as the key is number. because that is unique. The problem with dictionary is that you cannot store two values having the same key. So if I'm using name, then it will create problem because names can be duplicated, emails can be duplicated. I'm not sure though, but number is a field. I'm sure that numbers, they are unique, right? So if I store this data in dictionary, this is the way I can store. Number is set in the key field, and the remaining two attributes, name and email, I'm setting them in a list, and then I'm putting it in the value part, right? So now I can add as many entries as I want of this key value type, right? Now let's come to the functions. Add can be easily implemented in list. In fact, we don't have to implement it. List already provides a built-in function. In fact, two built-in functions for this: extend and append. So there is no issue. I can call those functions. In dictionary also, we have a built-in function called update, and that can be used to add more records in this dictionary. Okay, now let's talk about printing. We know that these built-in functions, they provide pretty ways of printing those items. I showed you for list in the last lecture. So if you are printing an object directly, list as well as dictionary, they both take care that the output is presentable and user understandable. So print is also not an issue for both the data structure. Okay, now let's come to sort. List provides a built-in function for sort, but there is no such function in dictionary. If you want to implement sort for dictionary, you will have to write your own function. Okay, so one plus point for list. And when it comes to search, the kind of search that we want to do here on my phone book, like we want to search an entry by first name or last name, that kind of search method is neither provided in list or nor in dictionary. So that means we'll have to write that function by ourselves, whether we use list or dictionary. Now if you see this, list is slightly better than dictionary, because if I use list, I will not have to implement that sort function, but in dictionary I'll have to do that. So I'll go with okay, this is first approach. Like we just use some built-in class and just write all the code in the main module and just go with it. The second option is, since now we know how to define classes, we can create a class for this phone book. So that's the second option. And when we'll do this, we'll see we'll have to use this list class internally as well to store data records. So the third option, which is going to be the best one, obviously I'll show that to you in today's lecture, is that I use I extend the built-in class list and I define my own class. So last 2 points, they might not be very clear right now, but let's start building the code and I'll show you pros and cons of each technique, and until we reach the last one. Let's try this first approach, in which we can write code using this built-in class list. I think this should not be a problem for you to understand, because we had been doing such things in CP a lot. So I can define an empty list, right? Contacts is the name that I have chosen for my two-dimensional list. Now, if I want to add context, I simply can use that append method. See here, I am using that append method, which is a built-in method that comes with class list, and I'm adding this record. First is the name Maria Vakas, then is the number. As I told you earlier, that I'll be storing this as a string as well. So this is some dummy number, and then we have the email address. So this is a sub list. You see those square brackets? So this is a sub list, and this will be appended to my main list, contact list. So that means contacts is going to be a 2D list in which I'll keep on adding a new contact this way. Similarly, I can add another record. This is your class advisor, Miss Ibshar Ishrat, and then her dummy contact number and her email address. Now, if I want to print this phone book, we know that when you print that object directly, it prints it, you know, in a legible way. So I can simply print it like this, right? I'm not showing you the output. You can just try this out by yourselves. I'm providing you this code in that code file though. And if I want to sort these records, for that also a list class provides a built-in method sort. So I only have to call this method sort, and that will sort the list. Okay, now as I told you that this searching method is not available with class list. So if we are going with this approach, we'll have to implement that function by ourselves, right? Now the problem with this approach is that this is procedural programming. Like you are defining contacts separately, and this function that we'll be writing for search, that will be uh, separate from the rest of the code. Like sort method and append method, they are part of list, right? But this search function will not be part of list. You will have to define it separately in your file, right? So that is also fine. Like there is nothing syntactically or logically wrong with that. But if somebody wants to use your code, he or she will have to use the function as well as the class list. Like whole thing does not come as a package for the user. So a better approach is that we define our own class and put everything in just one package or in just one capsule. Now let's come to the second approach. Here I'll define my own class, right? So here it is. I am defining my own class and I'm calling it phone book. Now in this approach also, I'll have to use a list internally because I have to store a list of contacts, and that cannot be done without using that built-in class list. So I'll be defining some instance variables of list type inside this class. But the difference of this approach as compared to the last one, or the thing which is better about this approach as compared to the last one, is that here we'll be able to keep everything together. Like that function search and all the other functions and that list, they'll all be packaged inside this phone book, right? That means they'll be it's like putting them in a single module or in a single capsule, which was not there in the last approach. So this is the object oriented approach, and we are trying to bind all the functions and the attributes together in a single class. So let's instantiate an empty list, and the best place to instantiate an empty list is in the initiator function. Sorry, in the initiator method. So first of all, I'm defining this init method, and the only thing that method is doing here is this. It's defining an empty list called contacts, and since I'm accessing it using self dot that operator, that means that this is an instance variable. Okay, second function that I'm going to define here is for adding contacts. Now you see, in the last case we were able to call that function append directly, and here also we can call this function on this instance variable contacts, but a better way is to define a method for this so that the user who is using our class does not have to use double indirection. Let me show you what do I mean by double indirection. So I'm defining here a method add contact. The user will pass these three values to this method: name, phone number, and email, and we'll use them to create a list entry, and we'll just put that entry in that list contact. So here I'm doing it. See, this is what I meant by double indirection: self dot contacts dot append. So self dot contacts means that I'm using an instance variable of my class phone book, and then this contacts is of list type, therefore I can invoke this method append on it too. So I'm just using the same method here to add this 1D list to my main list contacts. The second method that we need to define here is for printing. Now I hope you can recall from the last lecture that if I try to print an object directly in print statement of this phone book type, what will happen? It will print something which is not very understandable, or not very pretty. So in last lecture we saw that we can solve that problem by overriding a dunder method str. So I am overriding that method here. That means I am defining that method here. So now the next question is how I want my output to look when I print an object, how I want it to look on the screen. So the approach that I'm taking here is since I have to print a whole list, so the best way is to print headings first, like name, phone number and email, and under those headings I start printing the records one by one or the contacts one by one, right? So but the problem with this str method is that you have to compose everything in a single string, and that string is returned to the caller, which is going to be the print method later. So I have to prepare a string, so let's do that. Okay, I'm taking a temporary string here, strg, and I'm assigning these headings to it, right? So in the first line these headings will be printed, then \n means that next part will be from the next line. Now for the context, now I have to read this list contacts, the instance variable contacts. So now I run a loop for item in self.contacts. Now self.contacts is a 2D list. So if I use this for loop over that 2D list, item will contain each contact uh, in each iteration. Like in first iteration, it will contain the first 1D list, first name, first phone number and first email. Next time it will switch to the next record, and we have been doing this a lot in the last semester. I hope you all are able to recall it. Okay, so that means this item will contain one record at a time, right? Or one contact info at a time. Okay, and within that item I can access each piece separately by using index. Like name, item dot zero will refer to the name, item, sorry, not item dot zero, item 0 will refer to the name, item 1 will refer to the phone number and item 2 will refer to email. So see, I have concatenated this string, this new part to my that temporary string strg. So during first iteration it will pick the first name, the first phone number and first email, and it will concatenate it to my existing string. Then I'm appending \n so that the printing comes to next line. Then during next iteration, next record will be picked and it will be printed, then third record will be picked and it will be printed, and so on. So the output will look like headings first and then goes the records one by one, right? You can also add a serial number if you want here. Okay, so that's it. After I exit this loop, strg will contain all the information that is to be printed in a formatted way and as a single string. So I just need to return this strg to the calling function. Next we have to implement this sort function, and since that function is also available with class list, so I just have to define a new method, sort contacts, and I don't have to pass any arguments to it. And inside this method I'll just call the sort method of list type, right? So this is again double indirection, self.contacts.sort. Self.contacts is of list type, therefore I can invoke this method, this built-in method sort on it, right? So there is no issue, but I don't want my user, the user of my class, to call this sort directly from outside. So I'm providing a pretty wrapper of sort contacts. So user will only call object dot sort contacts and that will work. I'll show you shortly that when I go to the test code. The last function is searching, and as I said earlier, list type does not support any such function like the one that we want to implement here. So I'm leaving it again. For the next implementation I'll implement it only once in the last implementation. So that's it, the class is ready. Let's suppose I have implemented this search method, so the class is ready. Let's run some test code. Now in the main program, first thing that I would do is I'll instantiate my phone book. So book1 is of phone book type. Now I am adding a contact. So this is a method that I defined internally, add contact. I will pass these three values to this method, and these will be assigned to that 2D list, or we can say that these three will be neatly put into that 2D list. So, okay, let me add another contact, and now let's print it. Now let's see what output it shows. Now this, since I am printing that object directly using this print command, so that means that it will call str method automatically at the backend. And we implemented that str method to display the information in a specific format. So let's see if it appears at the output. Okay, here it is. Now here you can see the first line contains the heading name, phone number, and email. And then comes the first record that I just showed you. We fetched that from that instance variable contacts. And then came the second record from the same instance variable contact. And since there are only 2 contacts, so the list ended after 2. Okay, now let's call the sort contact function. It will sort the list, but it is not returning anything or printing anything. If I want to see my sorted list, then I'll have to print it again. So here I'm printing it again, and let's see the output. Okay, now the list has been sorted. I comes before M, so this is the sorted output. Now you can find this whole code in that code file that I've uploaded along with this lecture. I want you to try something here. Just go and remove that str method from the class and see what output does it produce. So this is your task for this this second approach. Just remove the method, run the test program, the same test program again, and observe the result. Let's go back to this slide. Now let's compare this approach with the first approach. The better thing here is that we have placed all the methods, including this search method, in a single capsule or under one umbrella of my class phone book, right? But there is something which could make us uncomfortable. Like if you notice this, like why do we have to call this method within a method? Like you see, sort, built-in method sort of class list is doing everything. So why can't we call this method directly from outside, from the main program? Obviously that can be done, but I don't want my user to use this double indirection. Like he might not be aware with that name contacts. I'm using this name contacts inside my class, and the user of my class doesn't know this name. So uh, otherwise this is quite possible. You can directly write this double indirection statement self.context.sort in the main program, and that will sort the list. So in order to hide the name of my instance variable, I'm using this approach. I'm using this wrapper of sort contacts, which is my method, and then I'm putting this method inside it. So this looks a little clumsy, like it is redundant, like I'm adding extra statements in my code. Same is the case with that append method also, right, where I was adding records. So we can solve this problem in our third approach. In third approach, what we'll do, we'll inherit from this built-in class list, and we'll see that this problem will get resolved over there. Now in this third approach, what I'm going to do, I'm going to define my own class like before, like the second approach, but this time I'll derive my class from the built-in class list. So here's the statement, right? Phone book is the name of my book, and list is a built-in class, and I'm putting that in those round brackets. That means this will serve as the parent class for my class phone book. Now since this phone book is inheriting from class list, that means now phone book can access all the methods that have been defined in this built-in class list. So my phone book now inherits all those methods. So now if I instantiate any object of phone book type, that will be able to access all the methods of this class list without any indirection. Like if I instantiate an object x, then x.append can directly access any that append method of list. I'll show that to you shortly in the test code. Okay, so this is the first method that I'm implementing, adding contact, but luckily I don't have to implement it right now because I can now directly call the append method of this class list. One more thing that I want you to notice here, that I don't now even need that initiator method, because list class has its own initiator method. Whatever I you know, whenever I instantiate an object, it will be instantiated like a list is instantiated. So it will automatically instantiate a list type instance variable for me. Now, if I want to print my object, since now I am deriving from this class list, and list prints an object in a specific manner. So if I want, I can just leave it like not implementing this method. So what will happen? We know that list, if you try to print a two-dimensional list, it is simply printed in a two-dimensional format, not that pretty format that we had been using in the last approach, but this will work. Like the output will be legible, readable, and understandable. So you can go with this. And if you don't want this and you want that pretty string, then you can provide your own str method, and this is the same str method, right? Now, one thing that you note here is I don't know what name this class list has assigned to the list that it has instantiated in its init method, because I am not defining any init method explicitly here. So whenever I instantiate an object of this phone book type, since I am not defining any initiator method here, that means initiator method of the parent class list will be called, and that will instantiate an empty list. But I don't know the name of that list. How can I access that instance variable? So for that, you can use just self. Now, if you see here in the last line, I'm saying for item in self. Although last time, since I had an instance variable name context, there I wrote self dot context. But here I don't know the name. I can just use self, right? So this is one thing which is different from the last implementation. So item in self will refer to that list that has been created by this list class init method. So this remains the same thing, and I'm returning this strg to the calling function. Next function is sorting function, and like that addition function, here also I don't need to implement this. I can directly call this sort method of the parent class list. Now if we finally reach our last method, which is searching by first name or last name, and as I told you before that there is no such method with this specification available in built-in class list. So that means this time we have to implement it finally. So here is the definition. Here I'm passing a name to this method search, right? And this name could be anything. It could be first name, it could be last name, it could be part of first name or part of last name, or it could be a complete name including first and last name. It could be anything. It's simply a string, right? And what we plan to do here now is we'll search this string in the name field of the records. Like we are storing contacts, 3 fields in a contact: name, phone number, and email. So what we'll do, we'll extract the name field and we'll try to find this in that name field. So if this is found in that field, then that means it has been searched. So another thing that we need to decide here is what I want. Should I return from this method as soon as first occurrence is found, or should I create a list of all the names which contain this string name? So it could be either way. So I'm going for the second approach, that I'll search the whole contact list and I'll gather all the records which contain this string name, and then I'll form another list. I'll create a new list, and then I'll return that list to the caller. Okay, so in this method, what I'm doing, I'm defining a temporary list called contacts found. And the purpose of this temporary list contacts found is that whatever records I find, I'll just put them in this list, right? Now, I could have initiated it to simple list type, but here I'm instantiating it to phone book type. Like I'm using the same class within the class. So okay, I'm giving you a minute right now or you can pause if you want more time. I just want you to think that what difference will it make if I instantiate context found to phone book, or if I instantiate context found to simple list type object. Okay, it was really difficult to wait, so I just waited for about 40 seconds. The difference is will be in printing of the object. Like if I instantiate it to list type, so what will happen when I print these contacts found? Uh, I'll return this context found to the calling program. So if this context found is of simple list type, it will be printed the way list prints an object, like in the form of a 2D list. But if I instantiate it to this phone book type, what will happen when I return it to the calling program and the caller tries to print it using print statement, then my str method will be called. That means that if context found is instantiated this way, it will be printed in a more presentable way. That's the only difference. So that's why I am instantiating it to phone book. You can change the code and instantiate it to list type. Working will remain fine, only the display will be changed. So you can try that with the code. So here I have instantiated an empty list of phone book type. The next thing that I'll do here is I'll traverse my list contact by contact. Right, my contacts, they are stored in a 2D list. So I'll traverse the 2D list contact by contact, and each time I'll extract one contact and I'll access the name field of that contact, right? And then I'll try to match this name passed as a parameter to this search method in that name field and see if it's there or not. Uh, okay, one small problem, not a problem, but I could have taken some other name in parameter field instead of name. It could be confusing, but let's see if you are able to grasp it. So this is the first thing that I'm doing. This statement will traverse my 2D list. So the name with which I'm referring to my 2D list, since I don't know the name actually, so I'm because it is defined in it is defined by the built-in class list. So I'm referring to it by using this self. So for item in self will mean that during each iteration, item will fetch one contact from my 2D list, right? And that contact will be composed of three fields: name, phone number, and email. So what I have to do, I have to access the first field of item, which can be accessed with index 0. So item 0 means I'm looking at the name field of my contact. So I'm just comparing this name. Actually not comparing, I'm trying to find this name using this in operator in the name field. And if it's there, what I have to do, I have to append this item to my contacts found list. Okay, during next iteration, next contact will be searched, and if this name is again found there, so that contact will be appended to my contacts found list. So that means by the time this loop finishes, contacts found will contain all the contacts containing this string, which has been passed as parameter to my method search, and I'm calling it name here. So after that, I just have to return this list to the caller, and this list will be of phone book type, right? Because I have initialized it to be of phone book type. So we are pretty much done with the class, and this looks a lot nicer as compared to the previous class. We don't have to implement any extra functions. So if you observe here, we have implemented only two functions, that str function because I want to do some pretty printing, and this search method. Otherwise, I don't have to implement a sort method or add method here. Okay, now let's run some test code. This is the first statement. I'm instantiating a phone book, um, and I'm calling it book1. Okay, now you see I am directly calling that append method. I did not implement this append method. This is a built-in method from class list. But since my class phone book inherits from class list, I can call this method directly on my object, right? So this is what this third implementation provides. Okay, let me add one more item and let's print this. We implemented that str method for phone book, so it should be printed the way we had assigned there. Right now you see this output is good, but you can even make it better. Like you can make it even prettier. Like you can arrange these in columns also. So if you see the code file, I have provided you an alternate implementation also, and that contains the formatted output that will print column wise these three fields: name, phone number, and email, properly aligned. But that's more related to formatting, so I'm not explaining it over here. Anybody who is interested can have a look at it and or can run that. And if you want to discuss or ask anything, you can ask me through email, right? Or we can discuss it in the live session. Okay, sort, same as append. I can directly call this sort method, and actually this sort method is implemented in the base class list, right? I haven't implemented in my class phone book. Let's print it again. See, the list has been sorted, and now I'm searching this string Maria. So see, this is returning a list. Since there was only one name that's contained MARIA, so it returned only one. But if you search like AR, yes, AR is common in both the names, in Ibshar and Maria. So if you search a string AR, you will get both the records printed here. So I hope you are able to see the advantage that this technique provides. Here what I have done, I have simply extended a built-in class. So um, if you have any issues, you can discuss that in the upcoming live session. One thing that I want you to do for this final implementation is I want you to identify the three types of variables: class variables, instance variables, and local variables in this code, right? If any. Okay, before winding up, I just want to do one more example, a very simple example that might help you recap the main concept that I wanted to discuss in this lecture, that is extending a built-in class. So here what I'm going to do, we all know about the string class. String class provide a lot of functionality, like you can call many methods like split and I don't even remember the name of the methods. So there are a number of methods that are supported on this string class. So what I'll do here is that I'll create my own string class extending this built-in class str, and I'll add another method here to count words in a string. That is not provided by the built-in class. So if anybody uses my class, he or she can have access to all the methods of string class, of the built-in string class, plus he or she can also call that word count method for strings. So let's implement this. This is going to be a very small code. So this is my new class. I'm calling it string with capital S, string string, and I'm deriving it from that built-in class str. Since it's a built-in class, you will see in idle it will change its color when you type it. So I'll be implementing only one method here, that is word count. Now there could be multiple approaches to implement this method. What I'll do here is that I'll simply split the string on spaces. We know that we can use that split function, simple split function of string str class, and I can split my string into words. Like if I split it on spaces, then it will be splitted into words, and those words will be returned in form of a list. So here's the statement. Okay, a simple statement. Now L is of list type. So L contains list of words in that sentence. So I just have to use that length function, len function on L, and I can return length of L. This will simply give me the number of words in my string. Here is a quick test code run. This is a sentence, okay, a long sentence. I'm Maria Vakas, your teacher for the course CS116. Don't count that slash because that is just for, that has just been used as continuation operator. So actually it contains 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 words. So if I call this method on this object sentence, it should print 10. And here it is. See, so we have neatly extended the class. Now this my class string, it can avail all the functionality provided by str class, plus it is providing one more additional method, and that is word count. So this is the gist of today's lecture, that you can extend a built-in class and you can enjoy all those already written built-in methods. That means you are reusing the code, right? This is the best, one of the best examples so far for code reusability. You can reuse that code and you don't have to write that again, and then you can add your own methods too, right? But you see, you have to be careful sometimes doing this, because there could be some built-in methods that could ruin your application. Like you don't want that particular specific functionality for your class, but since it is available in that built-in class, you have to you cannot stop the user from using that. So you just have to take care of that. Okay, so that's all for today. Thank you.